Okay, continuing with static electricity and an introduction to it, what if we want to represent charged and neutral objects? Well, in this example, there's a neutral object, a positively charged object, and a negatively charged object. In each of these examples, note that it's an atom of the same substance. So there's 6 positive protons, 6 positive protons, 6 positive protons. So these represent three atoms of the same substance, but 3 atoms of the same substance with a different charge. Now note these illustrations we have are super simplified. They are not like what we just described in a previous video or what you learned in chemistry, where we say, hey, the positive protons are in the nucleus and the electrons are in electron clouds around the nucleus. Yes, you could try to draw that way, but we want to get super simple, fast drawings. And so that's why we have these just way oversimplified, technically incorrect illustrations. But it's simple to say, hey, there's 6 positive protons, count them, 6 negative electrons. 6 minus 6 is 0, no charge, it's neutral. We come to this example, same atom of the same substance, but I took away 2 electrons. Because I took away 2 electrons, now it's 6 positive protons minus 4 electrons leaves a positive 2 charge. This is positively charged. Notice that if you want to change the charge to make something positively charged, you have to get rid of electrons, and then you'll have more protons. Now, if you take this atom with 6 protons and you decide to add electrons to it, now we have the same 6 protons, but now we have 9 negative electrons. So 6 minus 9 is negative 3. So this has a negative 3 charge. It's negatively charged. And so again, how do you charge objects? You either add electrons or you subtract, you take away electrons, but you never change the protons. All right, now in reality, something else to note here is that all objects have much more protons and electrons than this. These are simplified images because we know that there's Avogadro's number, 6.023 times 10 to the 23rd atoms per mole of a substance. So these are just oversimplifications to help us get the main idea. All right, now that's how you know something's charged. What about charge movement or attraction? So we know that different charges attract. We're going to do some fun demonstrations to illustrate this. Positive and negative charges attract. You see that in the picture here. But also positive and neutral charges attract. Negative and neutral charges attract. So if you have a negatively charged object and you bring it up to something that's neutral, they will attract. There's reasons for that that we'll get into later. So different charges attract. We know that like charges repel. So a positive and a positive will push away from each other. A negative and a negative will push away from each other. And we know that if you have 2 neutral charges, they are not going to respond to each other. They're just fine minding their own business because neither one of them has a charge.